let's do number 9.8 now. This is the problem where we're looking at accidents on a stretch of highway during the December holiday season. So we know that in any given month, the number of accidents has a mean of 7.6. So you look at the past 8 December accident reports and find your sample mean of 9.5 and a sample standard deviation of 2.2. Can you conclude there are more accidents in December with a confidence level of 0.1? So let's come and check this problem out and see how it compares. The first thing we need are the hypotheses. What are the hypotheses going to be? Well, if December is the same as every other month, then we know that the mean, I'll put my H naught here. If December is the same as every month, then we know that the mean should equal 7.6. And if December has more accidents, then that means the mean should be bigger than 7.6. So this is the default. If there's something interesting, that is if more people are getting accidents, then we'll get a bigger than 7.6. Okay. Well, after we've done that, we need to ask ourselves, what's our test statistic going to be? This one you have to figure out, do we know sigma or do we not? Well, we see a standard deviation. We have a standard deviation of 2.2 in our problem. But what's important is to read the words around the 2.2. And it says it is a sample standard deviation. Sample is the letter S, not the letter sigma. So since our standard deviation comes from our sample and not our population, sigma is unknown. We only know the standard deviation for our sample. So what does that mean? That means we have to use the t distribution and not the z distribution. So we're going to use t equals x bar minus mu divided by s over the square root of n. So we're dealing with t and not z, and that's going to help us as we go through the rest of our problem. So this is our test statistic. Let's put our numbers in. We got 9.5 minus 7.6 divided by 2.2 divided by the square root, and I think 8 was the number. Yeah, we did. It said the past 8 December accident reports, so that means our n here is 8. Now we type all this in our calculator, and when I did it, I got 2.44 for my result. Okay. So now that we have that for our test statistic, we're ready to start looking for our p-value. When I draw my p-value, I'm going to do this. I'm going to put 2.44 right here. And again, we have a greater than sign, so we're looking at the right-hand side of 0.244. And that's our p-value. Now we need to use t-CDF. We need to use t-CDF with a lower of 2.44 and upper of your choice of your favorite really big number, and degrees of freedom of 7 because our n was our sample size 8, so we always reduce 1 to be 7. And so this gives us our p-value. When I type this in my calculator, I get 0.022 for my p-value. P-values are generally what's reported when you read papers, so this is probably a number worth kind of noting and coming up to. Well, let's now finalize our conclusion. Our problem says to compare this to alpha equals 0.10. Now notice when we compare this, which is bigger, it turns out 0.10 is bigger than 0.2. So our p here is a small number. It's 0.10. So finally, we have a p-value that's considered a small number. What do small p-values mean? This means we reject h naught. In practical terms, what does this mean? It means that our stretch of road does have more accidents in December. So finally, we've proved what we wanted to prove. We proved that our average was bigger than 7.6, that our stretch of road has more than 7.6 accidents in December. So we're excited that we finally proved something, but we're a little disappointed that the thing we proved had to do with accidents. But all right, come back in the last video in the series, and what we're going to do is we're going to talk about how to make our calculator compute all this stuff for us, and I know you'll be very happy to do that.